Yes, that sounds great. Okay, so the recording has started. First of all, because I received a question by email from someone who cannot be here with us for this session, but as you already know, you can find should appear on the screen now. You can find all the slides and all the links that I'm mentioning and all the tools that I'm talking about. You can find them all on this website. I also trying to upload all the different slides to the Moodle of this course. And just before the course, you may have noticed that I have also uploaded a URL to a YouTube video. So if you go to my YouTube profile, let me see if I can show it to you on this screen. If you go to the YouTube or to my YouTube profile, there's not a lot there, but there is the recording for the first session that we did, for the second half, because we only started recording in the second half. I'm currently uploading the recording for the second session, and we're also recording this session so that you can have a look at merely all of the three sessions again if you would require. So the links will be on Moodle, and the links will also appear on the on this website where all the other resources are and where you can also download the slides. So just to recap, because we are in the third session and the last long session, or the last 3-hour session. So this session should be the most practical one of the three that we already had. We had some more theoretical background earlier and some more introductory stuff earlier. Today it's all about production, so producing actual data visuals. How do we go from our raw data in usually Excel or in a data file? How do we go from that to a finished data visual that looks nice and that works well in conveying our message? So it's a 3-hour session, so we will be working until 5 o'clock, maybe just after 5 o'clock. And then the final session, which will be on Friday, will be only 1.5 hours, but we'll start on Friday at 9 o'clock in the morning. Don't forget that there's a homework assignment. I will recap everything about that assignment at the end of the session, but just be aware that you have to send me a finished data visual by Friday at 9 a.m. at the start of the session. And then during that session, we will just have a look at all of your work together. I will try to give some feedback. Of course, there's not really a lot of time. We have 90 minutes for 18 different people, so that's just a few minutes per visual, but we will try to give some constructive feedback, what's already working in your visual and what could maybe be improved. But it's a required assignment, so I won't grade you, but I have to notify the organization whether you participated or not. So make sure to create a data visual. It will take maybe something like 2 hours. So take that into account, and between now and Friday 9 o'clock, you have some spare time to create a data visual. So the content for today, I tried to make it as practical and as useful as possible. I will first talk a little bit about, I'm not the world expert, of course, in data visualization. I'm not a guru, but I can try to give you an insight in how I work and what my typical workflow is to go from a data file to a finished data visual. I'm trying to include a live demonstration, so fingers crossed that that's going to work. It's always a little bit risky to include a live demonstration, of course. And we will talk a little bit about the available tools that you can use to create your data visuals. By then, we will already be halfway through the session. We will have our regular break, and then we will talk about components that you can add to improve your data visuals, like which colors do you choose, where can you find some icons or illustrations, or what fonts can you use, so some typography choices. And we will wrap up with some case studies, some visuals that we are going to improve, some visuals that I found somewhere and that we're going to improve, so that you can show how this process goes from usually removing noise from a visual and making sure that the message gets to the audience in a much better way. And we'll talk a little bit about visualizing uncertainty, because I think that's something that's a topic that regularly comes back when giving this class to researchers, and especially in STEM fields. Visualizing uncertainty is a topic that there's quite some discussion about, and I will show you some interesting options that you can do. And just a very little bit about interactivity, but there's so much to talk about interactivity, and it's quite difficult to do in a good way. So we're just going to mention it, but unfortunately, there's not really time to go into it very deeply. So the first part that we're going to talk about are the tools that you can use, or tools that I usually use in order to create a data visual. And first of all, the workflow. I might have mentioned it before. There are three main steps that I follow when I am creating a data visual. The tools that I use can be completely different, can be pencil and paper, or can be some online tool, or can be some software on my computer. But these three steps usually always come back. So first, we're trying to clean up the data. Raw data is usually a little bit messy, and we're trying to clean up the data and select only the data that we need to create our chart. Then in a second step, we will use a tool to actually create the chart from the data. And then in the third step, we will improve the design, because usually default charts that come from Excel, for example, or that come from online tools need some kind of improvement to make them work, or to make them even better. So cleaning up the data, what do I mean with that? This is an example. Remember when I talked about my Nobel Prize in Physics infographic? So I'm interested in people who won the Nobel Prize in Physics. And remember, I created a visual about how many women have won the Nobel Prize in Physics versus how many men. In order to create that visual, I had to first download the data. Maybe an interesting side note. I think it's not included, but I'm sure it's not included in the presentation, but I think it's interesting to note. Originally, when I was doing this, I had to write a little script in order to scrape all the data from the Nobel Prize website. So it was a little bit complicated to get to all this data. But nowadays, let me show you my web browser. Nowadays, there's a great tool which is called Google Dataset Search. It's like a subdivision of Google, and it's explicitly made in order to look for interesting open data sets. So, for example, if I'm looking for Nobel Prize laureates and search, I will get over 100 results. It's in Dutch, but I suppose that you can understand what's written here. Some of these will be open, some not. I think you can select it. Yes, if they're free databases. So, for example, the first result, Nobel Prize winners, all the winners for between 1901 and 2016. Well, that's already great. Let's have a look at the actual data, and then you are given a link to, there are a lot of these kind of data hubs online. If you're looking for a specific data set, usually if we're talking about visualizing your research, you already will have your data set on your computer. But if you don't, and you're looking for a specific kind of data set, you can find it online and then easily download it. So here are the data sets ordered by date, for example, and all the winners. So you don't have to jump through a lot of hoops in order to find the data. Usually it can be easily found somewhere online. But if you download it, typically it's like a CSV file, so a comma separated text file. And if you simply open that, let's say in Excel, it looks little bit like this, and which is a little bit messy. So it's not organized in columns yet. And also we did apparently something wrong with the encoding, because some of the special letters in some people's last names, like Wilhelm Conrad Röntgen, are completely messed up. So that's not really what we want, because otherwise we have to go through everything manually to correct it. The best way to avoid that, if you're working with Excel, is not simply opening the CSV file, but opening a normal Excel file and then using the import function to import a CSV file. And then Excel will know, for some magical reason, Excel doesn't know what to do with it if you just open the CSV file. But if you open Excel and then import the CSV file, suddenly Excel knows exactly what to do with it and puts all the data in the right columns, and puts also has the, you will have different options to choose the encoding, so that you won't have specific glyphs or letters which are not rendering correctly. We will do, this is just an example with some screenshots. We will do a live demonstration in a few slides, no worries. And then when we're trying to create a visual, so there's a lot of information here that we're actually not really interested in, because let's assume in this case that we're interested in the gender of the laureates, that we're interested maybe in the age of the laureates, to confirm, is it true that they're always old white people or not, that they're always old men or not. So we can already remove a bunch of columns that we're not really interested in, and maybe just let's just leave the columns that are interesting to us and that we can use in our data visualization, because otherwise we have a lot of overhead. And especially if we're using online tools, it will create a lot of difficult situations if we have too much data that's actually not really relevant for data visualization, if it's still inside the data file. So I typically, like you can see, create a clean data file that we can then upload and start creating charts with. So once our data is a little bit cleaner, and we have just selected the data that we need in order to create our data visual, we can start looking at tools that can help us in turning this raw data into a graph. And a first tool, which might maybe sound a little bit stupid, but I don't really think it is, because usually, or often, the best tool is a tool that you already know and that you can already work with quite well, and that you already have installed on your computer. So personally, I have created many graphs already and many charts simply with Excel. Of course, you have to look a little bit further than just the default charts. And this is an example for some dummy data. If you create a bar chart, for example, in Excel, and you use only the default settings, then you will get the chart which is shown on the left, which is not really, it's not bad, but it's not really pretty, and it's not really what we want, because there's still a lot of noise. There are still a lot of things that are not in the right place. And maybe at that point, you will be tempted to give up and to say, yeah, I can't create nice graphs with Excel, but that's definitely not true. I would suggest to use Google to find some tutorials in order to create nice graphs with Excel. For example, the graph on the right is actually, it's the same data, but and it's also done only by using Excel. But we have given it some extra thought and taken some additional steps. For example, we switched to a horizontal bar chart. We switched to two different bar charts instead of this double bar chart, which is on the left. and which looks quite a bit better. We have removed the legend and changed it by titles into titles, because legend here is not really relevant, not really useful. And because the grid lines, so the horizontal grid lines, are giving a lot of noise in this original default graph. Here I have chosen to completely remove the grid lines altogether and to show the data labels instead of the grid lines, so that this makes it easier, I think, to compare the length of the different bars. And if you want more details, then you can look at the exact numbers behind the data. And I think grid lines are in this case a little bit superfluous and can be avoided. And then, of course, we also have taken another color scheme, because the default color scheme in Excel, it's not really bad, but it's not really pretty either. And also, people will simply see that you have used the default color scheme, which might come over as a bit unprofessional. If you choose your own color scheme, and we will talk later today and in this session about how to choose a color scheme and where to choose it, and how to implement it in Excel or in another tool, you can create immediately charts that work a lot better. Let me just have a quick drink. So Excel definitely, although it's not a fancy tool, don't write it off as a possible tool to create a data visualization. Personally, I use it all the time. But to be honest, I will create a basic graph in Excel and then go to step 3 to prettify the graph in another different tool, and I will show that later on. But we're 2020, of course, and so there are other options as well, and especially online options. A lot of tools are popping up online in order to create charts. Some of them are quite basic, some of them are more advanced, some of them are free, most of them are like freemium, where you have a free version with limited capabilities, and then you have a premium version with more functionality. And depending on what you need, depending on how much you want to spend, depending on what your requirements are, you can use one or the other of these different tools. So, for example, this changes rapidly, so don't take my word on it that everything on here is correct. But for example, Canva is very widely known and it's very easy to use, especially for beginners. If you're not accustomed to creating visuals yourself, Canva is very easy, and you have a lot of templates and images, etc., that you can immediately use by simply dragging and dropping them onto the visual. But if you're trying to create charts, it's very limited. You can create, I think, pie charts and bar charts and maybe a scatter plot, and that will probably be it. Some other tools which are more focused on chart building or infogram and picture charts, but in those cases, the free versions might be a little bit limited, and the paid versions might be, they can do more, but they might be a little bit expensive. So those are definitely options, but personally, I don't really see the advantage of using such an online tool in order to create a graph, especially because you can already create some great things with Excel. If you want something more fancy than what Excel does, usually my go-to tool for that, or yeah, let's say one of my go-to tools is an online tool called Raw Graphs. And Raw Graphs is a tool where it's completely free. So personally, I think that's amazing, because the stuff you can do with it, and we will show it in the live demonstration in just a few minutes. The things that you can do with it, in my opinion, is really great. You can simply upload your data file, select the type of chart that you want, select the columns that you want to use in your chart, and then give it a go, and download the final result to use it further in the tool of your choice, in your presentation or in your article or poster or whatever. So that's a great tool and completely free compared to the previous tools that I mentioned. and it's one of my personal favorites. And then if you are a little bit into development or can do some programming, depending on the programming language of your choice, whether you are a Python fan or a R specialist or someone who can program in JavaScript very well, there are of course also many different options. Personally, I'm definitely not an expert. I'm not afraid to admit that I'm not an expert in this kind of programming languages in order to create data visuals, but the possibilities are obviously endless, but the learning curve is a little bit steep, and you have to know how to program, or you have to be willing to spend some time and effort in order to learn a specific programming language and specific libraries that come with it in order to create some data visuals, but you can do some great things. And I think especially the D3, if you go to the D3 website, there's a lot of examples of great interactive visuals that are created with D3. If you already know JavaScript, it's not very difficult to learn, and it's something that I see being used more and more all over the internet. So that's definitely one of the tools to check out. But for the scope of this course, it goes a little bit too far, I think to go into the programmable tools. Of course, those are just digital tools, and you're definitely not forced to use a digital tool if you don't want to. There's a lot of people who create great data visuals simply by hand, by using a pencil and paper and maybe some colors. Like Mona Shalabi is famous for creating this funny small data visuals like this one. Can be a little bit more elaborate and can be a little bit more artistic, like what Shelley is doing. Those are more infographics because it's very, very artistic, but he just uses hand-drawn diagrams and pen and pencils in order to create things like that. This is a little bit more qualitative than quantitative, but a famous hand-drawn data project is Dear Data. Let me have a look. I have the Dear Data book, but I didn't prepare it. Let me just take it. So great that online teaching allows you to walk around in your house. Because there's also a book about it, and I really like this book. So the Dear Data project is, are two girls, or two women, I should say, two data visualization designers. One of them, Stefanie Posavec, was based in London at the time, or I think she's still based in London. And the other one, Georgia Lupi, is based in New York. And they were both very interested in data visualization, but also in this kind of what they call data humanism, so a human factor part of the data visualization. So they were really attracted to hand-drawn and handwritten data visualizations, both of them, and they agreed that this would be a nice project to do. So what they did was, for one entire year, 52 weeks, every week they sent each other a postcard with a hand-drawn data visualization on it. So they agreed on a specific topic for each week. So for example, a week of sorries. And then during the entire week, they tracked how many times they said sorry to someone else, or maybe how many times someone else said sorry to them, and what the reason was, and how was it meant or not meant, etc. Things like that. Turned that data about their lives in that specific week. At the end of the week, they turned it into a hand-drawn data visual, and then they each sent each other a postcard with this hand-drawn data visual on it. So by the end of the year, they had 2 times 52 postcards with all these different kinds of hand-drawn data visualizations on them. Was a huge success apparently, because they have a website with many visitors. They created a very popular book about it, and they even those postcards were selected and are now part of the collection at the Museum of Modern Art in New York. So hand-drawn data visualization is definitely not something to be laughed at, and it's definitely an option if you want to create a data visual that works and that maybe attracts people because it has an authentic, like a human feel about it. So hand-drawn data visualization is definitely an option. Or why not use some real-life objects and then take a picture and use that as a data visualization? This is an example from National Geographic magazine, already from quite some time ago, which was used to show the amount of drugs or traces of drugs that could be found in our waters, that are polluting our waters and have an impact on biodiversity in water. And they created a data visual using different kinds of pills to create this image, and took a picture and created a data visual around it. So that's definitely an option. Or if you don't have that many drugs lying around, you can do like this guy who has created a data visualization using Lego. So it's like a bar chart, but simply using Lego blocks instead of creating it digitally on his computer. Or even if you don't have any Lego or any toys around, just look in your fridge and maybe there is something, some foods that you can use to create a data visualization with. This is just a little bit extreme, obviously, but just to show there's a lot of tools, and especially a lot of digital online tools available currently, but don't feel compelled or don't feel forced to use one of them. The important thing about the data visual is the concept behind it and the visual itself, and not the way that it's actually created. That really doesn't matter all that much. So if you have chosen one of those tools and you have turned the cleaned up data from step 1 into a chart in step number 2, then usually what we end up with is a little bit a bland or a default chart. Then we still have to improve the design a little bit further, especially for me, for example, because if I'm creating a data visual, I want to have all the labels on exactly the right spot in exactly the right font and with exactly the right color. And I want to have all the grid lines the way I want it. And usually these are things that are not part of a default chart or a default online charting tool. So then you need some kind of additional tool or software in order to pimp your designs, to improve them a little bit more. Because all these things play a part and are important if we want to get our message across to our audience, as we have already seen, I think, many times now before. So what I typically use, just to be transparent, but I suppose that's not for all of you in the cards. But as a designer, yeah, I have a subscription on all the Adobe tools. So I can use Adobe Illustrator for my data visualizations. I take the graph from Excel, imports it into Adobe Illustrator, and then I can start simply giving everything the colors, the exact colors that I want them to have, or the exact fonts that I want them to have, and sizes, etc. I can create some background, add some other visuals, everything. So it gives me a lot of possibilities to get everything in exactly the way that I want it to have. It's a little bit difficult to work with, but don't let that bother you. But the main drawback, obviously, is that it's quite expensive. So it's part of the Adobe suite, which costs, let me think, 50 euros per month. which is for me as a full-time self-employed designer, it's really not that much. But I can imagine if you're a researcher that that's not really in the cards. Um, but there are alternatives, so let me show them. But just I have included this as an example. It's not something that I created, but I included this as an example. This is something that there's no charting tool available online that helps you in creating visuals like this. If I look at this, you can immediately see, oh, this was something that's created with Illustrator or something alike, because everything is positioned in such a way, and the colors and opacities even of the different circles are created in such a way, the font is oriented in such a way that's not something that you can do with an existing tool. You have to create this with Illustrator or a similar software if you want to achieve something like this. But as I said, there are alternatives for Illustrator. Something which is already a little bit cheaper is, for example, Affinity Designer. Affinity Designer is it basically has the same. I don't really have a lot of experience with it because I am used to working with Illustrator, but Affinity Designer, as far as I understand, has basically the same or almost the same functionalities as Adobe Illustrator. But the difference is that it's not a subscription, so you just have to pay a one-off payment of 55 euros, which is maybe more manageable depending on how invested you are in design or how what your budget is. It's still little bit steep to learn, of course, because there's a lot of things that you can do with it and a lot of buttons to play with and to get to know. But it's not part of a larger suite of software tools. So you just have the designer tool. You pay 55 euros and then you have it for the rest of your life, and you can create all the data visuals that you want. So that's possibly a cheaper alternative to Affinity. And I see that it's already in the chat. So Inkscape is what I definitely also want to mention because that's the free alternative to Illustrator. I can't really give an opinion on it. It's probably very powerful. I have used it a few times, but also just to be honest and transparent, that must have been like probably during my PhD. So we're talking 10 years ago. I used Inkscape and I always found it very, or quite hard to use and a little bit difficult to learn. And then afterwards, I started paying for Illustrator, and which was also hard to use and hard to learn. But over the years, I started using Illustrator better and better. And for me now, working in Illustrator is extremely easy. And if I turn back to Inkscape, everything is completely unintuitive to me. But that's just because I'm so well used to working with Illustrator. But Inkscape also has the definitely a lot of the same possibilities that you have with Illustrator. But yeah, just to be clear, I don't have any practical experience how it goes if you take a graph from Excel, import it into Inkscape, how easy it is to manipulate it. That's something that you will have to experience for yourself, but definitely a good option. And I hear that many people are using it. Probably if you're trying to figure it out and trying to learn how to work with it, and you're stuck at something, try to ask around, and probably you already know some people or some colleagues who are using it, which could help. To be complete, I used a tool during my entire PhD, I think, also a free tool, which is called paint.net. It's like Paint, but on steroids. So if you know Paint, or if you have ever worked with Paint, you can do only some very basic image manipulation with it. But Paint.net, the largest advantage I think that Paint.net has is that you can work in different layers. So if you look at the specific screenshot, is one of the images from my PhD thesis. And if you look at the bottom right, there you can see an overview of different layers. So there's a background layer at the bottom. There's a layer with the actual data in it in the middle, and there's a top layer to add some annotations, for example. And it's basically similar to how Photoshop works. If you're used, or if you have ever manipulated photos in Photoshop, it also works with different layers. And the advantage with layers is that yeah, you can move things around, or you can edit parts of the image in a specific layer without messing up the other layers. So, for example, if you have a layer with annotations and you want to move the annotation around, you can simply move the annotation around, and the data visual, which is on the layer below it, will not move accordingly. So it's much easier to work with, where you have a lot more flexibility to work. And so this is a tool which I think I stumbled upon by accident, but it worked so well for me that I used it throughout my entire PhD. And I created all the visuals in my PhD thesis with Paint.net. If maybe you know the GIMP. The GIMP is, I think, another well-known alternative which lets you do image manipulation. The big difference, obviously, you probably know this, but just to be complete, or for the people who might not know it already, the big difference is that if you're using, for example, Illustrator or Affinity or Inkscape, you will be working with vector images. And if you're using Paint.net or the GIMP, you will be working with bitmap images. And to illustrate the difference, I have created this visual twice, once as a bitmap image and once as a vector image. And a bitmap image consists of pixels. So if you start zooming in on the bitmap image at a certain point, you will see the pixels appear. It's like a photograph, actually. If you're taking a photograph, it also consists of pixels. So you cannot zoom in endlessly on a photo or on a bitmap image, because you start seeing the pixels and the quality is becoming worse and worse. On the other hand, vector images, they are not based on pixels, but they are based on shapes and lines, and shapes which are colored in a certain way. And because they're not pixel based, but based on shapes, you can simply zoom in and continue zooming in on them, or making your images larger and larger and larger without you start seeing the pixels, because there are no pixels, they're just shapes. And in the background, the software is calculating how these shapes should look like and behave if you're zooming in a lot or if you're scaling it up a lot. So that's a little bit the difference. It doesn't really matter if you're creating visuals for your presentation, for example, but if you're creating visuals for to print on a poster, for example, or in your book, in your PhD thesis final book, make sure that if you're working with vector images, you will have no problems. If you're working with bitmap images, make sure that they have enough pixels, that the resolution is high enough so that they can be printed very nicely. But now we're talking about really design and desktop publishing stuff, which is completely out of the scope. But just so that you know what the difference is between Paint.net is a really great tool, but then you have to make sure that you think about the pixels and the image quality. If you use Inkscape, you don't really have to worry about it. Okay, that about the new tools that you maybe haven't used before. If you don't feel really comfortable to start using a new tool, I also have some good news for you. Because maybe you're thinking, oh my God, I need to create a data visual by Friday, and I don't know, I'm not really wanting to install a new tool or to learn a new tool. No worries, because you can do quite like in the same way that you can create some great charts in Excel, you can similarly pimp these charts very well in, for example, PowerPoint. Because PowerPoint sounds maybe a little bit stupid again, because we're used to PowerPoint as a tool simply for creating presentations. But actually what you can do in PowerPoint. It's, in my opinion, it's very powerful because you can, for example, draw shapes in any shape that you want, and you can put them on exactly the place that you want. You can give them exactly the color that you want. You can create text fields for which you can change the font and the font size and the font color. You can put them exactly where you want. You can draw lines and grid lines, color them the way you want, style them the way you want, place them exactly where you want. Um, Almost on a very like pixel by pixel basis, so you can be very exact in it. Um, and in this way, and it works very well together with Excel also. So for example, if you're creating a chart in Excel and you're copy pasting it into PowerPoint, and then you can start working on the colors and the positioning and the fonts. And with those two together, you can create some really great stuff. So this is, for example, a data visual which is created, well, to be honest, not entirely, but for a very large part, completely in PowerPoint. So it's something which is quite out of the box. Definitely not a standard Excel chart or a standard chart, but it's completely done simply by building different shapes and giving them different colors in PowerPoint. Okay, so that brings me to the most challenging part of this live presentation, which is a live demonstration. Pro tip, if you're ever giving an online course, don't include a live demonstration because it's a whole lot of stress. Let me first switch the screen to my main screen. Okay, so now you should be seeing my main screen. Yep. No. Put this away. Put my face away. Put your names away. So if everything went according to plan, yeah, I have a data file which I found online that I think could give an interesting visualization. Data file is here, music data. It's already as an Excel file, so it's not a CSV file, but it's already an Excel file, which is pretty great. But the basic data looked a little bit like this. Oh, this is even filtered. It was not filtered when I got it. Remove filter. Okay, so what we have in this data file is like really a lot of rows, over 3,000 rows. And what we're looking at is the amount of different kinds of audio media which has been sold in the period between 1973 and 2019. So if we just have a look at the formats, for example, so this is what the raw data that we download. So let us see live what we can learn from it. So let me start by filtering it. So the different formats that we have information about 8-track. You possibly me neither will remember what that is, but some very old media format. You have cassettes, CDs, downloads, some smaller things, but LPs also, streaming, subscriptions, ringtones, more vinyl. So all these different kinds of formats we have information about. We have information both about the units, so the number of CDs sold, for example, but we also have information about the value, and which is so the amount of money going around in the music industry. because of the sale of CDs or the sale of LPs or the sale of cassettes or streaming, for example. So I think in this case, we are more interested in the value, what we will see as we go about, but I think we're more interested in the value. And you should know there are two types of value here. You have the actual numbers of money going around in the music industry. You also have the adjusted values, and the adjusted values are adjusted for inflation. So these allow for a better comparison between $1 million in 1973 is not worth the same as $1 million in 2019. So the adjusted values compensate for that and make it a little bit more easier to make correct comparisons. And then for each of these formats, we have this data between 1973 and 2019. So for me, but this is not really very clean data to work with, or not very easy to work with. So I have made a second sheet where I have broken up this data. I have put the years all in a different row, and then made different columns for each of the different types. And then once we have it in this format, we can easily just have a first look. So we're not yet creating our data visualization, but just let's have our first look at what's maybe interesting in this data. It's a Dutch version of Excel, but it's I have to insert. Now in my mind, I constantly have to switch between English and Dutch, but we'll make it work. So we want to insert a graph. Let's have a look at maybe something like a line graph. Oh, you can immediately see that Excel and default doesn't really work well together. Let's see what we can learn from this. So we have a lot of different categories, but if we look at the graphs, only a few of them are really interesting. So for example, this first is very light blue one. I think it's other tapes. This is almost non-existent. So if we're creating a data visual, in order to avoid that we end up with a lot of lines or with a lot of categories it's making it more complex to the viewers than that we're actually telling them something. Some of these categories that are not really contributing to the visual could possibly be either like scaled down in color value, make it very light gray, or simply remove without actually harming the interpretation and the correctness of the data. Some of the categories which are really interesting, I think, are the dark green line is our LPs, so our vinyls, together with this first line are the 8-tracks. Then the orange line here are the cassettes, and the yellow line, which is really larger than all the other lines, are the CDs. But it has risen, and by the year 2000, these CDs apparently reached their maximum value. So nearly all of the money going around in the music industry was generated by the sale of CDs. And by now, this has completely dropped again. And there's the only thing nowadays that is really generating value in the sale of music is the green line, which are the paid subscriptions. So like Spotify and other streaming services are now the only thing which are generating a significant amount of revenue in the music industry, or at least in the sales of music. So that could be an interesting story if we're trying to look for a story to create a data visual about. And for me especially, it's this rise and fall of the CD sales. Also because it's so much bigger than the other categories, could be something interesting. But I think this line chart is, I don't know what you think, but in my opinion, this line chart is not the best choice to create a data visual. And And so let's maybe upload our data to raw graphs, because I like raw graphs and I want to show it off to you how it works. Let's upload our data to raw graphs. But before we do that, there's something else that I don't really like. So there's too many categories. There are too many different lines here, which are creating like a line spaghetti, like we talked about last session. I want to avoid the spaghetti a little bit. So I created a second sheet here where I have removed a few categories, like I said, like other tapes, which are completely irrelevant in this data set and in this story. And I have combined a few other categories together. Like for example, vinyl is consists of both the LP sales and the vinyl singles. So both the large discs and the small discs are included. The same for cassette is normal cassettes together, combined together with cassette singles. Because if we're telling the story about the rise and fall of CD sales, we're not really interested in, yeah, but how many of these cassettes were albums and how many of these cassettes were singles? That's not really part of the story. And that's just noise, which is actually distracting our audience from what we really want to share with them. We want to share with them what happened with the CDs. The same with streaming and with downloads. I combined them a little bit in some broader categories. So in this cleaner sheet. So let us go to raw graphs. Use it now. So this is the first screen that you will get if you go to raw graphs. You can paste your data if you're simply copy pasting, but let's say in our case that we want to upload a file. It was, I think, yeah, in my downloads. I will have to close this one because otherwise raw graphs will be complaining. So raw graphs is smart enough to see that there are many different sheets or multiple different sheets in this Excel file. And we were talking about the sheet cleaner. So let's use the sheet cleaner. And as you can see, it goes pretty fast. 47 records, which is correct. So the first one, he puts it in bold. So raw graphs recognizes that these are the titles of the columns. And then from row 2 until row 48, we have the different data. And he is smart enough to recognize where the commas or where the what the decimal point is, etc., etc. And then we can choose our chart that we want to create. We have a scatter plot here automatically selected, but I don't think scatter plot is a great option for this. You can have, what can you create with raw graphs? A B-swarm plot, I don't think is relevant here. Circle packing. Yeah, let's explore, for example, how would a circle packing look like. And then in the bottom part of the raw graphs tool window, we have the different columns here, and we can put them in the categories that we want them. Now let's take a stream graph. I think a stream graph is a great option. So a stream graph is a graph which gets so on the horizontal x-axis we have time going by, and the width of these different waves that you can see of these areas is scaling according to. So it's a little bit like a bar chart, or like a stacked bar chart maybe, because all the different values are stacked on top of each other, but it's made a little bit more continuous, a little bit more flowing, so you can clearly see that there's an evolution. So it's like a bar chart where it's like a merger between a bar chart and line chart, where the bar chart is great to show categorical data and a line chart is great to show evolutions. Stream graph is a little bit a crossover between the two, and it's also great to show evolutions, but also to make comparison between the different areas. So let's now see. There's one. There's an easy one. The date. So the date will obviously be the year. Um, and now we start having a little bit of a problem because um, he wants our y values. He wants it in the group box. Well, I'm difficult at finding my words to explain this, but that's for example the CD data. This is definitely not the graph that we are looking for. Um, maybe we should put this in size and CD in group. No, this is also definitely not what we are looking for. Diverging. Yeah, he's trying to do the right thing, but I did this on purpose to show that you have to fiddle around sometimes quite a bit to find out what raw graphs actually wants to see here. And the problem is that in this group box, he wants the different categories. In the date, he wants the year, that's right. And then in the size, he wants the actual values for these different categories. But the problem is we don't have a category column because we have created a column for each category separately. And raw graphs doesn't really know how to deal with that. For that reason, so I'm cheated just a little bit because I was expecting this error and I created. So we were talking about the cleaner sheet before, and because I ran into this problem while I was testing, I created another sheet, so the cleanest sheet, where I simply put all the data on top of each other or below each other. But I made sure that there's now a column. So there's still a column year, because we will need that in raw graphs in order to know the date for the horizontal axis. But now there's also a column which is type, which we will need if we are in raw graph to put in the group box. And then the actual values, or the sales values in this case, we can put it in the third dimension. So we had selected the cleaner sheet earlier, but actually what we want is the cleanest sheet. Let's select the stream graph again. And now this will work much smoother. Again, this is a simple one. So in year, we want to have that in the date box. Sales will be the size of how wide the stream graph has to be. And then group will be the different categories of our music formats, so our CDs, vinyl, etc. And then we get almost what we want. We get a stream graph of this music data that we originally downloaded. There are some things that we can further tweak, but I usually prefer to do most of the tweaking then in the third step. In Illustrator, for example, or for now we will do it in PowerPoint. But let's just see what the other options are. We could have the categories in a different order. This looks a little bit strange, I think. Inside out, no. Keep in mind that the story, yeah, I think this is a great one. Bigger to smaller, because remember that the story that we're trying to tell is how the CD sales have risen and fallen dramatically between 1980s and now. And I think this ordering makes this, so the green area here are the CD sales. And I think this ordering shows it a little bit better than if you use the original ordering. Here it's a little bit difficult to see because streaming and downloads and ringtones are popping up, but are making a little bit difficult to interpret how this is going down. I think the bigger to smaller order actually shows us better what's happening with first the growing part of the CD sales and then the shrinking part of the CD sales. Let me see what the options are here. No, that's not what we want. Here it is, everything is normalized to 100%, but that's not what we want. This is going both up and down at the same way, but I don't think, yeah, there's some value in that, and you sometimes see stream graphs like that, but in this case, I don't think wiggle, no, wiggle, wiggle, wiggle. I think, what did we have? Diverging? Yeah, I think diverging is in this case the best option for the story that we're trying to tell. Interpolation is how smooth everything is. This I think looks horrible. Linear is a bit too strict for what we're going in, because I think we're not really interested in the exact values here, but we're interested in the story. Cardinal, basis spline. I think basis spline is very suitable for what we are looking for. We can choose to include the labels, but oh, that's a very weird way of putting the labels. They're very, yeah, well, they're following a little bit the line. No, I don't like how these labels look, and that's a bit the problem or the limitation of an online tool like raw graphs, but it's the same with all the different online tools. There is no way to modify these labels, for example, to put them in the way that you want them. And I'm very finicky and detailed about my labels. I want my labels to look good and to have them in exactly the place and the font and the size and the color that I want them. And this tool does not allow it. So let's not show the labels, and we will do that manually in the third step of the process. You can also tweak the colors, but let's do that manually as well. Now all we want is just have these shapes, this raw data visualization, and download it. So in the final step is downloading this visual. So the first one is a SVG format, which is the vector graphics, so the ones that you can scale endlessly without having to worry. You can also download it as an image file, so a bitmap image with pixels, but then we will have very limited options to start to modify it, to modify the colors or the text, etc. So you can do that if you don't have a lot of time and this data visual already looks like how you want it to look like, then you can download an image. But in our case, we're not really going to do that. The JSON model is if you want to use it with a programming language further on. But in our case, I think we're interested in the vector graphics, and this is music data, whatever. Download. Let's just save it. Don't open it with Illustrator, because now we have our SVG. Yeah, as you can see, my computer already suggests to open it with Illustrator, but I want to show you today how we can do it in PowerPoint. So, oops, let's go to where we were. Let's live integrate this into PowerPoint. I want a new empty slide. And let's insert a picture. Not from here, but from, it was in downloads. Here's my music data pictures. Thank God, PowerPoint recognizes it as picture, even though it's a vector image. So that's great to already know. Oh, and this is the data visualization that we had. So this, for me, concludes step 2. We have cleaned up the clean data. We have used an online tool, but you could have also made something like this, very similar in Excel. Don't worry, but we have used raw graphs in this case to create the raw data visualization. And now let's go to step 3 and make everything a little bit cleaner or more as we like it. Because if you look at this, it seems like it's just one image and we can't really do a lot with it, but that's not true, because it's actually this is a group of different shapes. We can Yes, convert it first to a group, and then no, remove the group, and now we simply have the different shapes together. It's not very obvious in this way, but let me show you. Yeah, come on. WebEx is a little bit in my way for the controls. I'm sorry, I have to make it a little bit smaller, otherwise WebEx is annoying me. So let's, for example, select this shape, and if we change the color, you will see that we are simply changing the color of this specific shape, which is the vinyl sales in this case, or the cassettes, if we want to make the cassettes blue, something like this. You can see, so now we can start modifying, and PowerPoint allows us to start playing around with each of these different shapes individually. And the same is true for the text, for example. This is too small, in my opinion, these little labels on the x-axis. So I want to maybe something like this. Not really liking this font. So let us take a font which is a little bit nicer. Personally, quite a fan of Bahnschrift, for example. And I actually had a nice idea. If we want to make this visual a little bit interesting, let's make it a little bit bigger so that it fills the slide. Also here, ooh, no, that's not what I wanted. I want just the shapes. Why are you doing this to me? Something like this, stick it to the bottom. We can grow it a little bit like this. I think this is a little bit more, if we're creating a data visual, is a little bit more impactful if we want to share the story. No worries, we will definitely do something about the colors, but that's for a little bit later. So let me select the. So these things, no. PowerPoint is a little bit fiddly, and you will notice that I'm used to creating data visuals in Illustrator and not in PowerPoint, but okay. So this will maybe work better if we make them white. I would like to remove that line, okay. And then just to conclude this demo, you can work, and this is a life lesson if you're doing data visualization, you can work on data visuals endlessly. Yeah? So they're never finished. You can always find new things to add or new things to remove or new things to change and improve. But otherwise the demonstration would take forever. So we're going to stop here and dive into more detail a little bit later, or do some more things a little bit later. Let me just put in a title. So the rise. Wow, PowerPoint, really. The rise and fall off. Now I want this to be bigger. In my favorite Bahnschrift, but maybe doesn't have to be condensed. Let's make it bold. And this can be, let's say, open sounds. Something like this. And we'll talk about adding some annotations and tweaking the color scheme and doing a little bit more with this data visual later on. But I hope this has demonstrated how we can, starting from the raw data in Excel, clean it up a little bit so that it's easier to work with, easier to create a data visual with. Then you can use either Excel or an online tool or something else to create a basic data visual, then import it back to a design tool, in this case PowerPoint, but could be just as well Illustrator or Inkscape, and start modifying away and change the things the way that you want to change them. So now I think I have talked a little bit enough for now. Yeah, let me switch on the presentation again, and then change to the other screen. This one exactly. Get my annoying face out of the way again, and get your names out of the way again. Okay, so I will now be quiet for 20 minutes and give you some time in order to have a look at all the tools, have a look at, I don't know, Canva, Infogram, picture chart, try to create something in Excel, try to modify something in PowerPoint. If you want to give Inkscape a try, definitely do that. Let's take 20 minutes of free exploration time to have a look at the different tools. And if you have any questions, just drop them in the chat and we will answer them. And then after these 20 minutes and the answers to any questions that there might be, we will have a short break. So I will see you again in 20 minutes, and make sure to drop any questions you have in the chat to be answered afterwards. Where's my pointer? Okay. This was paused. Okay, so there is one question in the chat by Sabolch. Why exactly do we need the online tool in the middle of the workflow? Is there no such offline program that can do the cleanup, the analysis, and also create an acceptable vector graphical plot too? Do we really need to depend on online tools? That's a great question, and no, we definitely don't need to depend on online tools. First of all, it all depends on the tools that you are accustomed to use and that you want to use, that you choose to use. In this specific example, I find myself going to online tools when I want to create a graph which is a little bit different, like for example, a bee swarm plot, or then I don't really know any kind of tools, unless you're really used to working with R, for example, to do your statistical analysis, and you know how to work with R and the different libraries of R, then you create plots directly using R. But I'm not really accustomed to it. I'm it's a little bit ashamed to admit, but most of my data analysis is quite basic, so it's done with Excel, and then I can create the kind of graphs that Excel can create. And sometimes I want something more exotic as a graph. But actually, this kind of wait a minute. Yes, you. So this kind of stream graph, I think we can perfectly mimic in Excel as well. Let me have a look. Talking about offline tools. So this was the Excel data. If we select it, I think we can use, no, not this one. Insert. we can create just as well this kind of stream graph in Excel. Excel is a little bit too stupid and doesn't really see that year should not be included here, and that this actually should be the years. Okay, that's a little bit better. And then we can also change the ordering a little bit if we want to bring the CDs on top of the graph, like we had in the raw graphs example. We can do the same thing with Excel and then copy paste the graph from Excel to PowerPoint. And there is a second question by Alemayehu Taye to show us how to label the previous visualization. Now it will get very embarrassing because in these cases, when there are just 8 categories, I will usually tend to label them manually. But we can do it now. Otherwise, I was probably going to do it after the break. But if this is a little bit small and boring. It's maybe a little bit too something like this, and do exactly the same, just 8 times here, probably for this color, but we're going to change the colors anyway. This is final, and I would simply do this by hand because we're just talking about 8 labels. When you have more labels, I would, for example, look at Excel, and I think in Excel we can add labels. Oh, those are not the labels we are looking for. Yeah, in Excel it's a little bit, it really depends on the specific data that we're working with and the specific tool that we're working with. Labeling is something that is quite often a manual job. It probably seems like a monk's job that takes a lot of time, and indeed that's usually the case. If you follow, I follow on Twitter, for example, people who are full-time map designers, so they do nothing else and create beautiful maps. And a large part of their job is simply labeling. If you see these very complicated artistic maps with different kind of labels, these labels are very often placed almost manually on the graph. There are even YouTube videos, hours long, where you can see people working in Illustrator to place labels manually on a map. Simply because it's something that really has to be quite custom, because, for example, yeah, it's easy to place a label here for CD and for vinyl. But for example, streaming is already a different case. This is the purple one here, and we can simply put streaming here because it takes up too much space. So now we should have to start deciding, maybe we can make it smaller. Maybe we can rotate the label a little bit so that it fits inside the category, or maybe we can do something completely different and make it more, put the label a little bit further away, and then insert up a line, for example. Yeah, PowerPoint really in that way. And then insert a line in order to link the label to the actual data. In this case, to make it a little bit more clear, but we will discuss it when we are talking about color schemes. It's probably smart to give the label the same purple color or also purple color so that we know that the label is related to this specific area of the chart. But this very much depends on the exact data, the exact shape of the data, and the exact story that you're trying to tell. So this is something which is very difficult to do with the digital tool, and it's something that I usually do in the very last step in a manual way. Okay, that brings us, I think, perfectly on time. Oh no, we're 15 minutes over time, but no worries. We will have a 15-minute break, so we will see each other again at 4 p.m. For the final hour of this session. And we'll talk about how we can optimize the colors, how we can introduce or optimize the typography, introduce some images, and then we will see some use cases on creating and improving some more graphs as an example. Okay, so let's meet again at 4 o'clock. Okay, welcome back. I hope you could all have a drink or a snack and stretch our legs a little bit. So we can dive into this final part of the session. Doesn't work yet. Okay, and so as already introduced, we'll talk a little bit first about additional components that we can add to our visualization, and then we will go into some specific case studies. So for the components, I want to talk a little bit about color. I want to talk a little bit about images and illustrations, and I want to talk a little bit about typography. But mainly about color, because color is so important in creating a good data visualization. And as we have already seen a few times, it also really helps a lot to tell our story or to bring our story to the audience in the way that we want it. But yeah, choosing the right color scheme is definitely not easy, and also not for me. I don't have a background as a designer. I don't have an official training as a designer, and I find it very difficult to simply come up with a color scheme out of nothing, a color scheme that works well for a data visualization. I have a go-to tool. Again, it's a little bit it's an online tool again, but it's one that I really like. Let's see if I can give a small demonstration again. Whoop. Howdy. So Coolors is like a color scheme generator. You have different, very similar tools, but the goal is just to quickly generate a color palette or a color scheme that you like and that's aesthetically pleasing at the same time. So let's click the button and see what this does. So we get immediately a suggestion for a color palette, and simply by hitting the space bar, Cooler will start giving us different kinds of color schemes that work very well in a design way. And if we don't like it, just hit the space bar and to get a new one, get a new one, or get a new one. And if you think, oh, I missed one that was actually really nice, you can simply undo and go back to the previous one. that's one part of why using such a tool is easy, in my opinion. What you can also do is, for example, say, oh, this pink, how's it called? Paradise pink in this case, is a color that I like, and also this yellow or this golden color, but the three others, they can change. Okay, then you can click this lock and simply start again, hitting the space bar, and the cooler will lock these first two colors that you have locked because you like them, and it will give you color scheme suggestions for the other colors. Will continue rotating. Or what you could also do is where is it? Um, you could change if you have a specific RGB value, for example, of a color that you want to use. You can select a specific color. So like this color definitely needs to be included in my color scheme, lock it, and then unlock all the other ones. And then Cooler will start giving you color schemes with the specific color or colors that you have indicated that you want to have in the scheme. And it will give you schemes that work with it, and many other things, of course, favorite color, different shades of color if you need lighter or darker shades to compare how it works together with the other colors, or if you want to switch to a lighter shade, what it does. Okay, I think you can also even, yeah, if you need 6 colors or more, or less, all of that is not a problem. And then if you have a color scheme that you like, yeah, I'm thinking a little bit about our vinyl data visualization. What you could do is let's, for example, say that we want to use this color scheme. What you can then do, or the easiest way, there are many different ways to get these colors into PowerPoint in this case. You could simply write down all the values, the RGB values, and then create these colors in PowerPoint. But something that works pretty quickly is exporting this as an image. This is my color scheme. Okay, and now it is downloaded. So now we have this color scheme as an image, and we can, let's copy and paste it into PowerPoint, for example. Pop, pop, pop. So imagine that this was our PowerPoint that we're working in. This was our visualization. And now we want to use the colors of our color scheme that we just downloaded from Coolors, and we want to use it for this visualization. Let me paste this color scheme, put it a little bit to the side. We're not really interested in this exact image, but we want to have this image somewhere near our slide so that we can use these colors and pick them using the color picker. So for example, the CD area or portion of the graph is, we want this one to draw the attention, so we want to give it a little bit of an accent color. So let's say that we want this orange color for this large portion of the graph. Then we can go, so we can select the CD portion of the graph, go to the color of the shape, and instead of choosing one of these colors, you could create your own color in this way, but you can also choose for the eyedropper tool here. In Dutch, it's pipette, but it's in English, it's eyedropper. And click here on this orange, and then you immediately have this orange color from our color scheme in the visualization. And then let's say for the vinyl, we want the more bluish colors from the color scheme for the different, for the old, the vinyl, the cassette, the 8-track. something like this. And then for maybe the streaming, we want the greenish colors in the color scheme to have a little bit of a differentiation. This was the downloads one. So let's say we want this. And then, ooh, this small one is a little bit, I know this is also vinyl. This one here is the ringtones. There's a little bit of special case. So let's say that the ringtones get this gray color. So now we have everything in the color scheme that we downloaded from Coolors. Now we don't really need it anymore, but you can keep it there if you want. It's not really important. So now we have turned, in a very easy way, we have created a color scheme that works, and we have applied it to our data visualization. We have to change, of course, make a few modifications because this dark text on this pretty dark red background doesn't really work very well. So maybe a white label will be better in this case. This was streaming. And this is now green, so this should be some kind of green color. And so on and so on, if you want to continue the labeling. Let's get back to the presentation. Okay, so that's for the color scheme, and a tool like Coolors will generate a lot of color schemes for us to choose from, and that work very well. But of course, there are some guidelines that you can use to quickly see which color scheme would work for your data and which one would not. For example, you could think about the psychological traits that we associated with colors. This is not very strict and rigorous, but it gives some kind of indication. For example, blue is something that we associate with trust and with stability, and that's why organizations that want to show that they are trustworthy, like banks, they will often have a blue color scheme or a blue logo to show that they offer this kind of trust and stability. If you see a red color, this indicates energy and passion. I think this speaks for itself. And yellow is more happiness and warmth. And if you remember my think back to my Nobel Prize in Physics visual that had a brownish, golden brown background. And that's because brown is a color that we usually associate with history, with intelligence, things like that. So if you have a specific theme that you want to recreate with your data visual, then maybe this could be a great starting point for a color scheme to look for. There are other ways to find color schemes. For example, Canva has a great blog post about where they have 50 or 100 different websites, and they have analyzed the color schemes which they use, and they have extracted these color schemes from these websites so that you can reproduce them if you would like to. Or they also have a blog post with different stunning photographs from which they have extracted the color schemes, which you can reproduce and use in your own data visualization, for example. As we have already seen a little bit in the music stream graph data visualization, one important guideline is if you want to tell a story, so you want to draw the users or the viewers' attention to a certain part of the visual, then it's good to use an accent color, and an accent color is obviously a color which is so distinctly different from the rest of the color scheme that it easily draws our attention. So this is again an example of pictures from my PhD thesis. I don't think it's not from the book, but it's from a poster which I created. And in this case, I used pink as an accent color in the figure on the left. It's not included in the data visual, but it is it's included in the text to draw the attention to the value of 45 minutes. On the right, it's included both in the text and as well in the data visual itself. So the three compounds that I didn't create myself are just in a neutral green color, and the compound that I did create myself and that outperforms the other three is in this bright pink that draws the attention a little bit. And also because there is some of this pink both in the text and in the visual itself, it also creates a visual link for the viewer between the two. So if you're talking about a certain result in the text and you're also showing the certain result in the visual, you can give it the same color and the viewer will automatically link those two together. So you will create, if you think back to the first session, you will create some effective redundancy because what you're trying, the story that you're trying to tell, the message that you're trying to convey is both in the text and in the visual. And because of smart color choices, they're linked together to make it even easier for the reader to see what's going on. Some minor guidelines or things to talk about, to think about when you're choosing a color scheme is accessibility. If you're really creating visuals for a large audience, be aware that quite a large or quite a significant fraction of people, especially men, are colorblind. So try to choose a color scheme that works also for colorblind people. There are different websites where you can check is your color scheme really suitable also for people with different kinds of color blindness, which color schemes do work, which color schemes don't work. This is something to keep in mind if you're really aiming at a very broad audience. Then accessibility obviously becomes very important. And otherwise, because for example, the red versus green color scheme, as you can see here on the top left, doesn't really work well for people with color blindness. So if you do use it somewhere in a presentation or in an article, make sure that there's also some redundancy so that people, even if they're colorblind, they can still see, okay, what's red and what's green. Like think of, for example, of a traffic light, which is very difficult for colorblind people who cannot distinguish red from green. But they can still see, okay, is it the top light which is burning or is it the bottom light which is burning? Okay, it's the bottom light, so it will probably be green. There's some redundancy so that you don't only have to use the color, but also due to the location of the light, you know which of the lights is burning and if you can go through or not. And the same you can do if you're creating visuals which don't have a perfect color scheme for color blindness. Make sure to include some redundancy. There's also some debate going on about gender data. If you are creating visuals and you're making a distinction between men and women, try to avoid stereotypes like using pink for women and blue for men. There are alternative color schemes. There are great articles about this. I think again on Data Wrapper, who always have great articles about these kind of things and techniques and guidelines with an overview of how news media, for example, and the leading news media in data visualization are using alternative color schemes nowadays, which are somewhat related to these cliché, these standard colors for genders, but they are just a little bit different so that we're not using overly used stereotypes. As I said, the Data Wrapper blog has some very interesting articles about it if you want to read more, because we could talk for hours about colors and color choices, but there's so much to find on the internet already that you can easily read. So this is, I think, a great starting point. And I have highlighted some of the key results that you just, it's great to be aware of if you're creating data visuals. For example, think about consistency. If you look at the data visual on the left, which is the not ideal data visual, the not perfect data visual, what's wrong here is that China is in both of these visuals, both in the line chart on top and in the pie chart on the bottom. But on the top, China is colored in blue, and at the bottom, China is colored in red. And there's also some blue visuals, so that makes it's an additional hurdle for the viewer to interpret these charts because the colors are changing in between the graphs. And if you're looking at the graphs on the right side, here China is blue both times, and UK and Germany, which are different countries, also have different colors. So that makes it easier for the viewer. Again, you're removing a barrier for the viewer to understand what's going on. Don't only use consistent colors. Also try to use some logical colors. So if we're talking about good and bad, don't label the good in red, for example. Things like that. Here you see a few different examples. If one of the data is about water, maybe think about using a blue color, so that otherwise you are introducing additional mental switches or hoops that people have to jump through in order to understand what's going on. Color schemes with different gradients of the same color can work very well, but it can confuse things a lot if you, for example, if you have different categories. So in the music data stream graph example that we just did together, we had 8 different categories. So we tried not to use a color scheme with just one color and different shades of this color, but we tried to find a color scheme which had some different distinct colors so that we could separate visually the different categories from each other for people to, that's easier for people if you compare the 2 images on this slide, for example. It's much easier for people to find where the data is that they're looking for if the color scheme is distinct enough or has several distinct colors to look at rather than just gradient color. And then finally, if you're using a color scheme for maps, for example, but works in other places as well, a rainbow gradient going from blue to green to yellow to red is used quite often, but it's something that can actually be confusing because if you look at it, you don't really intuitively know. For example, comparing yellow and green, you don't intuitively know, okay, is yellow higher than green or is green higher than yellow? And red is dark red. Is that a lot or is that a little? Is blue, is that what does blue mean? So a rainbow gradient can work in certain cases. I think maybe in when we're talking about temperatures, because hot is associated to red and blue is associated to cold. But usually if we're not talking about temperature, then maybe, and especially in maps, a lightness-based gradient could be a much better choice, as you can see in the example on the right. That's about colors. Images and illustrations. It's not really, of course, a core element of a data visualization, but it could give data visualization just that little additional touch, and a go-to source, for example, for icons. Maybe you can also use this in other places if you're creating a presentation or I don't know what. The Noun project is, for example, a free site with really millions and millions of different icons that you can use in many different styles and that you can simply download even in the color that you like and include them in your presentation or include them in your data visual. Just to give an example, this is a graph that I've shown earlier already when we were talking about balance, where I have included 2 icons, or a few icons actually, because there is also an icon for men and for women, to make it just a little bit more visually interesting than a simple bar graph. And it also helps the user to the viewer to understand that we're talking about sports here. So this was the percentages of men and of women who are actively playing or participating in sports. And these icons make that just a little bit more clear. So I think that works here very well. Notice again or also notice that the color scheme here, I try to avoid typical pink for women this time. Try to choose for a different color scheme. Jasmine asks which kind of tool I use to generate these double-sided bar charts. I think in this case, this was just created with Excel, where I created two separate bar charts and one going one way and one the other way. Now I have to think if the bar chart going the other way was actually possible in Excel, or maybe I just created it two similar bar charts, one for men and one for women, and then in PowerPoint, for example, or this was probably done in Illustrator, but you could do the same in PowerPoint. Simply mirror one of the two, and then you have this kind of double-sided bar chart. So it's a little bit more do-it-yourself work than it maybe might seem. It might seem like a really great created chart, but it's actually just I was messing around a little bit and mirroring different things, and then it turned out like this. If you want something more than icons, if you want illustrations, for example, then my go-to site is freepik.com, but there are, again, many other different sites. But you could start to check out Freepik and see what's available on there. A lot of images, again, in many different styles to give your data visualization maybe just that little bit more if you have to give an important presentation, for example. I have used an example of a Freepik illustration, also again in an example that we have seen earlier in this course. I think again in the first session on balance. Here, this is a visual for in a report showing survey results about people eating meat or people eating vegetarian, and so the organization is trying to convince people to eat more vegetarian meals. So this is like a soybean running around, a happy soybean, but that I just found on Freepik and included in this visual in order to give it just that little bit more a more informal feeling and a little bit more fun to look at than if it would just be the bee swarm plot, for example. This, by the way, is a visual which was created in raw graphs. In raw graphs, there's an option to create this kind of bee swarm plots, and I don't really know many other tools in which you can do this in an easy way. So that's just an example of how it looks like in real life. So that's for illustrations. And then finally, a little bit about typography. Again, I could talk for hours about typography, but I think the only interesting thing if you are creating data visuals is maybe the distinction between a serif text or a serif font and a sans serif font. So a serif font are these fonts like, for example, Times New Roman is a very common example. Where you have all these little edges and these little, it's called serifs on the side of the letters that give these letters a much more distinctive shape. And this is perfect for body text because all these little edges and hooks and serifs make it easier for our brains to read and to recognize the letters much more quickly because the letters are more distinct from each other, and that's why for larger areas larger pieces of text, so body text, serif font is usually a better choice, and a sans serif font works better to create titles, to create words that need to draw the user's attention. For example, if Apple announces a new iPhone, they will use a sans serif font to do so because it is more in your face compared to a serif font. Now, how does this translate? Um, I'm not entirely sure why I put this example in the presentation, but I think it's yeah, I'm pretty happy with this visual, with the typography and how it turned out here. I think yeah, the guideline or the rule of thumb is in a data visual, choosing a type or a font which is too complex is usually just adding additional noise to the figure, which is taking away the attention from the visual itself or from the story. And choosing a font which is more boring usually helps on focusing the attention on the actual story that you want to bring. Boring, I mean, yeah, in data visualizations, a sans serif font will usually be a better case than a serif font. And the fonts that you use should not really play or take the front stage in the data visualization. Otherwise, you're just introducing more noise. That doesn't mean that you have to stick with very boring fonts like Arial or Verdana or I don't know. If you want to find fonts that are a little bit more special or just a little bit different from the fonts that everyone is used to, you can also find them online. Um, dafonts.com used to be my go-to site for different kinds of fonts, but nowadays Google has a great alternative where you can type in your own text and you can filter if you just want to see sans serif fonts or serif fonts. You can filter if you want very bold, dark fonts, or if you want something very light or something that looks handwritten. You have hundreds, maybe even thousands of different fonts, and they're all free to use and free to download. So if you're looking for a font that's just a little bit different, like I think in this example, if you look at the titles, that's not a it's not a really in your face font, but it's not a standard font that's usually installed in your computer. So this is a custom font that I looked for that tried to do the job perfectly the way I wanted it. Um, that was for the second part of the demonstration, but I think I will skip that and go directly to the case studies. The most important part of the demonstration was showing how the color scheme worked, exporting it from Coolors and using the color pickers to color your data visual according to the color scheme that you selected. You could do the same. We could do the same with typography and show how we can choose a font. But I think looking at the time, it's better to have a look at the different case studies and then wrap up the session for today. Let me first have a drink. Okay, so the first case or the first thing that didn't really fit in another category that I want to discuss with you is visualizing uncertainty, because this is something that regularly pops up if you're a scientist, if you're a researcher and you are creating scientific publications, oftentimes you have to visualize that the data that you're showing has a certain uncertainty associated with it. And then a visual like this one on the slide now is a typical example of what you will then see, which is a bar plot with these kind of whiskers drawn on top of it, showing how uncertain the data actually is. But just look, I know that this is a kind of a standard way to represent uncertainty, but if we take a step back and look at it in an objective way, it's actually a very weird way, I think, to show what's going on and to visualize the uncertainty, and especially because, yeah, the bar itself is actually the more precise value, and the whiskers are indicating an uncertainty, and the bar here has like a lower opacity and it's larger, well, the whiskers, which are indicating the uncertainty, are very thin-lined and very strict and very exact. So it doesn't really feel like the whiskers are showing the uncertainty and the bar is showing the exact value. It's a little, it feels a little bit like the other way around, or at least it feel. I know it's difficult to explain myself, but it feels like this is definitely a suboptimal way to show uncertainty that's going on, and well, it can even be more suboptimal. It can even be worse. What some people call a dynamite plot, when you only show one of the whiskers because the other one is just symmetrical. But in this way, I think it makes interpretation very difficult and very difficult to compare, for example, category A with category C, because you mentally you have to take into account the different confidence intervals when you are trying to compare these, and in any case you have no idea about what's actually going on. This is from a paper, for example, showcasing that, yeah, in this case category A and B look completely the same, and category C and D also look completely the same, but maybe a better way of visualizing is showing the data that actually behind it, like here, and then people can see that, okay, category A and B, they're completely not the same. Maybe the mean value and the standard deviation is the same, or the uncertainty is the same, but that doesn't mean that the underlying data is the same. And the same goes for category C and category D, which look the same in the dynamite plot, but if you have an actual look at the data, are completely different. And then you also see the gray outline in the figure on the right of a box and whiskers plot, which is also an option to visualize uncertainty. But yeah, maybe not really one of my favorites. My favorite option is if you can show the data and then maybe give some indications about where the mean is and how big the standard deviation is. But now you can see that, okay, where there's a dot, there's really an exact data point. There are some other possibilities to indicate uncertainty, and those are very well explained in the two articles that I linked to on the bottom right of these slides. So, for example, here on Klaus Wilke shows how you could indicate certain confidence intervals, also showing that, yeah, the farther you are away from the mean, the lower the possibility becomes, or the greater the percentage that the actual data falls within this confidence level. This one possibility. I think he gives certain other possibilities, certain alternatives, and I think, yeah, option C is maybe then the most realistic one, and the most simple one also, where you're just showing the mean as a point and then use whiskers to show the confidence interval. But I think this kind of dot plot is much better suited than using a bar chart, for example, because a bar chart makes it a little bit difficult to start interpreting what's going on and how big the confidence intervals actually are. You could use a gradient or maybe like a Gauss curve to show, but maybe that's a little bit a step too far. But it all depends on you and the underlying data that you're trying to convey, what option is maybe the best to visualize the uncertainty. Or if you're doing simulations, for example, and many different simulations, they are all centered around a certain mean with a certain deviation or confidence interval, then you can simply show the different locations of the simulation results. Each give them a certain opacity, and where they overlap will be also darker, and then it will be for the viewer very natural to interpret where the mean value is and what the spread is in or how the confidence interval actually looks like. And then I think final example is this one. Yeah, then especially the part of the image on the right. I think it's interesting because this is actually completely switched around from the first image. So in the first image, the actual data value was represented by a bar, so by a rectangle, and then the confidence interval was indicated by a very thin line. And here it's actually the other way around. So here the actual data value is indicated by a dot, by something more exact, and then using a light gray bar or a light gray rectangle, the confidence interval is indicated. I think this is it's both a practical way, but also I think it's a better way to show a confidence interval compared to the first example, which is maybe more or the standard way or the classical way, but it's not because it's the standard way and many people do it that it's actually the best way. I think options like this or the ones that we saw in the previous slide or the ones that you can find in the articles online are often a better choice to show a confidence interval. When I give short talks about data visualization, I try to end up with like a checklist that you can use if you are trying to create a data visual. That just some different things that we then talk about or that we highlight. You don't really have to interpret as an exact checklist, but it highlights the different things that we talked about, and it maybe is a good way if you think you're almost finished with your data visual to take such a checklist with you and go through all the different points and see if you maybe have forgotten everything. So we have started with that was already like last week. Is my story clear? Also in my own mind, do I know what I want to talk about, what I want to tell, and what message do I want to share? Is that clear for me? And is it also reflected in the visual that I have created? Then, as we have also seen last week, do I really need a chart? Maybe I can, instead of creating an entire data visual chart, I can maybe just do with a number or with a table. Maybe you can do lots of great things with tables. Then did I choose the right chart type? So we have seen, yeah, you can go for a pie chart, or in case of doubt, probably a bar chart is the best option. But maybe there are other chart types that work even better for the story that you're trying to tell. Today we have talked about the color schemes. So is it clear? Does it align with the story that I'm trying to tell? Do I have an accent color if needed? Are my colors accessible also for people maybe with color blindness? Then is my chart easy to understand without additional explanation? Remember the chart that I posted on Reddit and got a lot of negative comments on because it was actually quite difficult to understand. So whenever possible, try to ask feedback from your colleagues or maybe from people who are completely outside of your field. Show them your data visuals and ask, is this easy to understand? Is it clear to you? Or maybe you have to add some additional helpful pointers to make clear what's going on, or maybe you have to remove some unnecessary design elements because they are creating more noise and so they're actually working against interpreting what's going on for the viewer. And then finally, it's always great to have a look at if you're writing a large body of work, for example, an entire article with different visuals in it, or a poster with different visuals on it, or a PhD thesis with how many images are there in a thesis, maybe 100. Are they all consistent? Because consistency helps the viewer to interpret more easily and more quickly what's going on. Just to start talking about consistency, to show what I mean, I collected some different images from my own PhD thesis and put them all together. And then by seeing them together, you see that yeah, that they also work together, that they are consistent, and that they are all created in the same style, uh, with the same color choices, same fonts, same font sizes, for example. And this all makes it easier for the reader. The access when the access are all in the same style and created in the same way. Um, the viewer doesn't have to each time look at, okay, how is this axis constructed? How does it work like? What's going on? Because it's always in the same way. The color scheme is always in the same way. Viewers don't have to look like, okay, what's going on here? What's the important thing here? No, it's always red is an important highlighted thing, and the same basic green color scheme that's coming back every time. Um, Then I have two small cases of figures. This one is from a scientific publication, uh, one that I encountered and that I thought, oh, this is actually quite a nice topic, but unfortunately, the visual is, in my opinion, not really as strong as it could be. So what we're looking at here is psychologists, I think, who have done a study looking at how people use Instagram and which filters they use. I think it's an older version of Instagram with more available filters, but okay. And they have looked at, they compared which filters do people use or do healthy people use compared to people who have a tendency for depression or a higher risk of depression, and compared um, the filter usage between these two different groups. And if there's a difference, and so the larger the difference between these two groups, the larger the bar will be in this bar chart. And this is the result. So this is the output from the statistical software, I think. Um, and I think this is nice and interesting, but I think this can be further improved. First of all, let's make sure that viewers don't have to break their neck in order to rotate their head 90 degrees and read what's going on with these different filter names, these different categories. Like we already mentioned earlier, also, if you have a bar chart, and especially with many category names or long category names, please simply rotate it by 90 degrees, and it will immediately be much more easy for people to read and to interpret what's going on. Put something out of the way. So simply, this is maybe even the biggest change. Doing 80% of the work to make this a much clearer visual is rotating it 90 degrees. Then I wanted to take it a step further, and I found it a little bit difficult. Okay, I understand that we're talking about the chi-squared difference, which is a squared, so always a positive value. But I thought it would be interesting and more clear. Now here, a part of the bars are colored in red, and the other part of the bars are colored in blue. And in our Western culture, we associated bars that going to the right with positive, and bars going to the left with negative. I thought it would be interesting to maybe mirror the bottom part so that the bars for the filters that people with a tendency for depression tend to use are going to the left, and bars that healthy people tend to use more are going to the right. Just to make it, this doesn't change anything to the data, but by changing the presentation a little bit, it makes it. I think it makes it just a notch more easy to understand what's going on. Then another thing that doesn't work, I think, is the color scheme. As we have seen just a few minutes earlier, healthy is not something that we would associate with the color red, and depressed not something that we would associate with the color blue. So I think we can choose a better color scheme. And in this case, I chose for the color scheme. So healthy is maybe green. It seems to me a better color to associate with healthy people. And then for depressed, I chose a color that goes well together with this green, but has a little bit more of a, I don't know, negative connotation. And in this case, this purple, I think, works quite well to make the contrast. Shabosh, I will answer your question as soon as possible. What you also mentioned here is that I have changed the axis a little bit. So the axis here was only on the top, but that makes it a little bit difficult, I think, to compare different bar lengths with each other, and especially if we're at the bottom of the graph at the crema and the inkwell filters, it's almost impossible to see what the actual value is and compare it with the other ones. So instead of an axis, I used grid lines, which are a little bit subtle and in gray and on the background because they're not really important. But if the viewer wants to compare different bars with each other, they can use the grid lines to do so. And there are additional pointers also at the top to actually explain what's going on. So people don't have to read the text, but they can immediately see. So we also don't need a legend. Here there is still a legend at the bottom, but here there are just pointers at the top telling that, okay, bars that are going to the left are used more frequently by depressed users, and filters with bars going to the right are used more frequently by healthy users. And then finally, and maybe this, Shabels, answers your question a little bit, because I also thought that there was a lot of a white space here, but instead an axis break could be an option, but to be honest, I don't think that would be a good idea here, because the difference between the largest two bars is not that extreme, and it's quite interesting here, I think, also to know this exact difference. And if you would introduce an axis break, it would make it more difficult to compare. But the solution that I chose to fix this a little bit, well, I wanted to do something with all this additional white space that was there, and also make it more visual in one go. I have included, because we're talking about something very visual, we're talking about Instagram filters. I wanted to show to the audience, okay, but how does it actually look like? So I've included a picture of myself, a normal picture, and then a picture with the Valencia filter and a picture with the inkwell filter. And this again gives us more information, because if you look at the Valencia filter, you see, oh, this is like warm, soft colors. Maybe, start to understand why healthy users use this one more frequently. And the inkwell is a filter in black and white with very high contrast colors. Maybe there's a reason why people with a tendency for depression have a preference for this kind of filter. So I think this helps in telling the story. And I think two more things that I changed here is the color scheme. So I wanted really, if you look at the previous picture, there's not really a story here going on. And in this picture, I have highlighted the Valencia filter, so the most extreme one at the top, and the inkwell filter, the most extreme one at the bottom. And the other bars, I made them a little bit more lighter, so that they are a little bit more on the background, because who has time to look at all these different filters and to draw their conclusion? I wanted to highlight the key difference by highlighting the two most extreme values. That's one of the things that I changed. And I also changed another little thing. I don't know if you noticed, but I changed the title to give it a bit more, if you remember from the first session, the original title was Instagram filter usage difference between depressed and healthy users. That's a great what title, because it tells what's on the chart, but we don't want a what title. We actually want a so what title. We want a title that also conveys what the story actually is. So while this is a good title, but not great, here the title is now Healthy and Depressed Instagram Users Tend to Choose Different Photo Filters. So here the title gives the same information, but also gives the story. If we as a viewer don't know anything going into this chart, we just read the title and we look at the data visual, and I think it's easier to see what's going on compared to the original. So here's the original and the final value side by side. and there's basically exactly the same data behind it. But yeah, we have tweaked a little bit, mainly the orientation, the colors, and the grid lines. I think have done the majority of the work in improving this graph. My apologies. Okay, and I think I have a second final case study. Oh, there's a slide gone from my. There's a slide gone missing from my presentation. Ah, it's hidden. Okay, that's why it's gone. Unhide. Ah, it's because I tried to do it as an exercise, and that's why I've hidden it so that it wouldn't be already in if you had downloaded the presentation beforehand, that you don't have the end result. That's good because we still have 10 minutes left, so we can still do this exercise. This is another case that I found. This one is not from a scientific article, but it's from a presentation. I think that you can agree that there are some things that can be improved in this visual. So I want you to write down. I will not give any of my opinion about it. Let's take a few minutes to write down a few things that you would improve. Maybe put them in the chat so that everyone can see them. What would you improve in this visual? And then at 5:05, we will come back together and to see what all your suggestions are, and then we will see. I have done a redesign of this visual and see maybe what things did I pick up, or maybe you picked up things that I didn't even notice. And so let's see each other again at 5:05. And Pedro, I will also answer your question then. Okay, let's see what you have identified as problems with this graph. Oh, there's a lot of text. Okay, great. Now, I will try to summarize it. Yeah, the location and the size of the pie charts. Yeah, they are arranged in a zigzag pattern. That's right. So there's not really a link between the year of the data and where the pie chart is. That's true, and also their size is not really related to the total value. Yeah, the one in 1991 is smaller than the one in 2015, even though we're talking about a smaller amount, 587, or a larger amount, 587, 578 compared to 534. Wow. And also, yeah, it's a little bit double up or over the top that we have both the total value and then each of the individual values. I think that's true. Yeah, the percentage and the value next to each slide is way too much. I think it doesn't really help in telling the story here, depending, of course, on what exact story that we're trying to tell. But all these different values is just too much for anyone to take into account. Someone would change the color scheme. I think that's also a great choice. The color scheme is a little bit too much in your face. I think in this way, maybe use horizontal bars. That could be a good option. So go away from the pie charts and go to horizontal bars. Maybe show evolution with line graph. That would be very interesting. more harmonic color scheme for different sectors, remove the tough values. Yes, a better legend. An area chart. Oscar suggests an area chart. I think that's a great idea. Let's do that in the next slide. Let's see how an area chart would look like. Mauro also mentioned the title, which is indeed, yeah, it's a very good, it's a what title, but it's definitely not a so what title, so it doesn't really tell the story. Make the pie charts the same size, yes, or relative to the total value. That would indeed be good. Change the color scheme, yeah, it's a stacked bar chart, yes. I think indeed would also be a great idea. And quite a bit messy annotation. And then finally, Dimitri, there are at least two messages, one about the water consumption and one about the source. Yeah, that's true. I think we need to focus on one message here, and that we have to get rid of the pie charts and change the color scheme and maybe get rid of a little bit of the labels. So I don't have any in-between steps here. I just have the final results to show, but this was what I made from this visual. So indeed, a line graph or stacked bar chart or area graph, they would all amount to the same thing. This is an area chart, which I think works well in this case. One thing to note here is that the different points in time are not equidistant from each other. So there's a lot more time between 1991 and 2015 than between 2015 and 2020. So if you put the time on the x-axis, take into account here that there are different spacings in time. So I made it into an area chart. I also changed the color scheme a little bit so that they're all shades of blue because they're all related to the different origins of water. And the one thing that where I decided to focus the story on, because I also changed the title to give it a little bit more of a story. So supply diversification will increase San Diego County's water supply reliability. So while in 1991, 95% of the water came from one source, in 2035, we will have a diverse range of sources. So I gave the one water source, the Metropolitan Water District, which was in 1991 the biggest one. I gave it a different color from all the other ones. So all the other ones are shades of blue, and the brown one is then the one that we're talking about. And I removed quite a lot of the labels, and actually I only left the ones that we are interested in, which is the 95% and the 18%. I think is the most important one to see that the importance of this one is definitely dropping. Sabolch is giving actually a great suggestion. I was a little bit distracted while explaining this visual because I already saw this. And indeed, this area graph, it does hint a little bit or suggest a little bit that there's a linear change between 1991 and 2015, for example, or also between the other data points. Yeah, that's indeed, yeah, it's suboptimal. That's true. And I think a stacked bar chart would be a more correct, a more, depending on how correct you want to be, but stacked bar chart could avoid this problem altogether. Yeah, that's a great. Now I want to see how it looks like with a stacked bar chart, but okay, I will have to do that in my free time to see how it looks like. That's yeah, really good point. I think it works like it is now, but I want also to see the alternative. Then finally, blub, 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 blub. Yes, the homework assignment is now coming up. This is the final slide before the homework assignment, just about interactivity, because there's not enough time to go into it, but just some pointers that there are online tools with which you can easily create interactive charts with some hover effects, which you can click on, etc. I have included some examples here on the slide and some websites where you can find them. And usually they have very great tutorials to show you and to tell you how they work. And the homework assignment is so the final slide. Ideally, you can take one of the concepts that you have sketched from the previous assignment. So in the first session, I gave you some sample data sets in the, to extract messages from. In the second session, the assignment was to create some concepts simply by sketching them with pen and paper. And where the idea now is to use one of the tools that we have seen today, or use one of the tools that you would like to use. Actually, you're completely free. But all I want to see by Friday 9 a.m. is a data visual by you. Even if it's not about the sample data, if it's a data visual about your own work, I want to see a data visuals. Interactive figures, Oscar, are definitely allowed. Then simply send me a link. It says here through Moodle or through to email, but yeah, I don't exactly know if it works through Moodle. So email is maybe the safer choice, but we will make it work. And at Friday 9 a.m. we will sit together. We will have a look at the different data visuals and just have a little bit of a discussion to see what works and what doesn't work. And where possible, try to include some of the things that we have seen, like give it a title that's descriptive, that tells a story more than just telling a what. Try to use colors that are, that's easy on the eyes. Don't use default colors, but try to look for a color scheme that works for what you're trying to tell. Try to think of what type of chart do I want to show. Is a pie chart a good option here? Is a bar chart a good option? Do I want to use something more exotic? Everything is allowed, but make sure that you have something by Friday 9 a.m. We will sit together and spend a few minutes on each of your responses to wrap up this course. So I will see you again Friday at 9 a.m. If you have any questions, send me a mail. I'm very busy between now and then, but I will try to answer wherever possible. And then I have nothing left than to wish you a pleasant evening, a great Thursday, and see you again on Friday. Bye and thanks.